Okay, it's 3 p.m. We're going to get it started. Hello, everyone. Thank you for joining for our second meeting of July for the DBA virtual meetup group. We do have a Twitter handle, as you can see on the screen, so give it a follow if you are a Twitter user. Of course, you must be knowing the meetup group. That's why you are here. You also have a LinkedIn group. You can scan the barcode and join. We do post in our meeting details also on that group. And spread the word about this new platform. We started this when PaaS, ceased its operations. So it really doesn't cost us any more money or time or effort if more people join and take advantage of these awesome speakers that we get twice a month. So tell your colleagues, tell your friends, tell in your local user groups. We do meet twice a month. Second Wednesday is the noon Eastern time, and fourth Wednesday is the Pacific time. So like today is the fourth Wednesday, so we are meeting at 3 p.m. EST and noon in the West Coast. We do record if the speaker gives us permission. So we ask every speaker if you can record and post it in our YouTube channel. And John was kind enough, so we'll be recording today and we'll post it in the YouTube. We also share all our slides and code, or at least to share the GitHub link for the speaker. So you can go and download those later on. These are some of the future sessions actually I listed till the end of the year. So we will be skipping 2 meetings. One is for Thanksgiving, one is for Christmas break. Other than that, we are pretty booked for the whole year. So keep an eye. Next week is actually 2 of the Microsoft engineers are coming, talking in the next meeting, talking about the recent DBA toolbox. I'm also really looking forward to Anthony's 2 presentations in the same month. It will be a series on containers. Do you want to speak? So, we welcome new speakers. So send me an email in that email address if you want to speak, and send me an abstract. Then I can work with you. Or any feedback. What do you like? What you don't like? What you can improve? Send us a note, right? Constructive feedback. If you just tell me you don't like something, I cannot help. Tell me, what I can fix and why you don't like it. These are some other events. So I'm not going to list this, but I'm going to put a shameless plug here. SQL Saturday Boston, October 8th. I'm the primary organizer, but of course, I cannot do this alone. I have a bunch of awesome folks who's going to help me out. So if you're around New England, please register. We have 2 awesome pre-con. Look those up. If you are a speaker, love to speak in-person event, not afraid of flying like John, or you can drive, submit a session. It's in Sessionize, or ping me on the side. I can send you the link. And the big event, right? PaaS Summit, hybrid, in-person and remote. I will be there for the whole week. I'm flying there. I already reserved. I have, so I'm looking forward to it. Take a note of the dates, look it up. If you're not comfortable, at least join virtually. And thank you. John was kind enough, and John is going to talk about ADR, accelerated database recovery. So without taking any more time, I'm going to hand this over to John.
Yay! Thank you, Tom. I appreciate it. I'm gonna go ahead and share my screen so y'all can see the slides. Sounds like I'm from the South, but I'm not. I'm from Indiana. Go ahead and turn on my camera so y'all can all see me. As you can tell, I'm in Wrigley Field right now in Chicago. Not really, but that's where I pretend to be. I got my Chicago Cubs hat on. And my Microsoft Azure. Forgot I got my Microsoft Azure shirt. All right, so welcome, my friends, to this session on accelerated database recovery. It is one of my favorite newer features in SQL Server 2019. I will say it's my favorite feature in SQL Server since Query Store. That's saying a lot because I love Query Store. So we're going to get into accelerated database recovery. We'll start off first of all, though. Who am I? Like, who is this guy? Who's this dude that's just talking to us right now? My name is John Deardurff. You just call me John because no one can pronounce my last name. I am a data and AI cloud solution architect for Microsoft. I've been a Microsoft certified trainer for 22 years. I'm also a regional lead for the last 10 years and a former MVP on data platform. There's my email address on the screen. If you want to get a hold of me, my Twitter is at SQL MCT because I am the SQL Microsoft certified trainer. My website is surprisingly SQL MCT, and so is my GitHub. Apparently that's my branding. I also have a YouTube channel with no videos on it, but it's also SQL MCT one of these days. I've been saying that for 3 years now, 4 years. But this presentation and my demo script, I think Tao mentioned that he would send a link out to my GitHub. My GitHub does have this slide deck and my demonstration code that we will get to. I'll walk through and show you ADR for accelerated database recovery. We'll have an awesome demonstration on it that you can actually take that script and in a test environment, non-production environment, you can play around and practice with accelerated database recovery. You can submit your questions. And see Tao put that in the chat box. I am monitoring the chat, so I can see you just put that, and I will answer questions on the fly if you need to ask a question. So awesome, awesome, awesome. So we'll go ahead and get started. This is one of my favorite things, as I mentioned in SQL Server 2019 and later. It's also an Azure SQL database. It's in Azure SQL managed instances as well. It's on by default, as we will see. But for this session, this next hour, 54 minutes, we'll try to stop right at 4 o'clock my time, 1 o'clock Pacific. We'll start off with what is accelerated database recovery? Why do I geek out so much about it? Because I love it. Up there in the chat box, there's a link where you can find, I actually have a lot of repositories there, a lot of demonstration code on my GitHub, just to kind of point at that chat box. You can borrow any of my code, any of my presentations. If you want to deliver this session at a SQL Saturday, feel free to borrow, steal anything you want. My code is my own. It's not supported by Microsoft. I have just legal disclaimer. So if you borrow anything from me, it's my own presentation, not supported by any corporation. It's my own. So use at your own danger. But again, feel free to borrow anything you want. If you're a first-time speaker, I'm not sure if you want to be a speaker, I already built stuff out there. So if you want to borrow it, just give me credit and say, hey, John gave me this, or I borrowed this from John. You know. So I'm always trying to, and if you have questions about presenting, feel free to ask me as well. But this session is, like I said, we'll start off with what is ADR. Then we'll look at our current database recovery process. I say current since at least 1998. I started working with SQL Server 7.0, 6.5, 7.0. When I started working with SQL Server, I know going back to 1998, this is the process we've had. So we'll go through by current, the last 24 years being current. We'll walk through that process to kind of identify the pain points that we currently have with the recovery process, because there are some pain points. That's why ADR was introduced. Then we'll look at there's 4 core components that we'll look through. That's the magic that's built into the new recovery process, or the accelerated database recovery process. This will take about 20 minutes. Well, hopefully about 12 minutes. I was looking at the time. 12 minutes, we'll go through a little lecture, maybe 20 minutes, and then the rest of the time will be demonstration. If we don't get all the way through the demonstration, like I said, you could borrow the demonstration code. I do have a stopping point in there in case we don't, depending on time. But you can download the code, and it's very straightforward, as you'll see. You can walk through the step-by-step through the instructions if you want to practice with it. So we'll go ahead and jump into it. That wasn't too bad. So what is accelerated database recovery? Or we'll just call it ADR right now, or the presentation will last 2 hours. But I have to keep saying accelerated database recovery. ADR was introduced as part of the database engine in SQL Server 2019. And you can use it in 2019, and you could set the compatibility level on older databases to possibly use as well, as we'll see. I'll show you that in the demonstration. But it's a complete redesign of that recovery process, not the restore process. If I accidentally say restore, I mean recovery, because those are two different processes. Where at the restore, you're just copying the data from a backup back to your server, and then you have a recovery process after that. Or when your server reboots, or Bob is in the server room and he trips over the power cable, which, why is Bob in the server room? Get out of there, Bob. Get out of the server room. But if something bad happens to your server, when the server reboots, we have to go through that recovery process, even if I'm not restoring. And the recovery process is basically making sure that my database is going to be in a consistent and durable state as part of our asset properties with transactional-based databases like relational databases in SQL Server. We talk about the asset properties: atomic, consistent, isolated, and durable. Those are your asset properties of a transaction or transactional databases. If you're not sure what those are, I do have a blog post, shameless plug, for SQLMCT.com. I do have a blog post on asset properties or transactions and stuff like that. I haven't done a blog post in about 6 months because I've been lazy. But anyway, so our current recovery process, I think that's where I was. But now we have ADR. Or some of the benefits of ADR, as you can see there, why I get very excited. The two big, when they introduced ADR, the main purpose was to improve the performance of recovery. How much does it improve? From hours down to milliseconds. And yes, I said that correctly. You could, if your recovery process is currently 3 hours, 5 hours, 10 hours, with ADR, it's going to be milliseconds. 1 millisecond, 2 milliseconds. If you don't believe me, we'll see it here in the demonstration. A very fast and consistent database recovery process. Rolling back your statements. So it's fast, as we're measuring in milliseconds now. Get so excited I started stuttering. Very fast in milliseconds, and still making sure my database is consistent to meet those asset properties: atomic, consistent, isolated, and durable of our transactional databases. Instantaneous transaction rollback. I can roll back a transaction during the recovery process, but also as I'm writing code. If I have code that's running, and during running that code, there's an error and I need to roll back the transaction, it happens in a matter of milliseconds as well. Previously, it could be, if that code had been running for 10, 12 minutes, 15 minutes, 45 minutes, and you ran into an error, which, if that's the case, go back and look at your code. You shouldn't have, well, there are cases you have transactions that run that long, but maybe you should relook at your code if it's running that long. But in that scenario, that rollback process, rolling back, is going to take going back to the beginning of that transaction. With ADR, you're going to get instantaneous in a matter of milliseconds to roll back a transaction. So it's not only helping with the recovery process, but also with our error handling process, rolling back those transactions, which also means, as we will see, very aggressive log truncation. This is the aggressive log truncation. This is the side benefit that we get from ADR. It was kind of, as they were building it, was like, hey, we also have smaller transaction logs, smaller by megabytes or gigabytes, depending, which means lower maintenance of our transaction logs, or less space. I know I have customers, I have friends who play with SQL Server, customers, clients, who have entire drives just for a transaction log, just because they have very long running transactions. And those long running transactions fill up that transaction log. And it's always auto growing, so we don't get the error 9002, the transaction log is full. But with ADR, I'm going to have much smaller transaction logs. We'll see that in the demonstration. I know some people never believe me on that one, but we're going to save a lot of space because of that transaction log. And another side benefit, reduces contention on your TempDB database. Unintended consequences that happens, which is a good thing. The TempDB database stores, if you're using snapshot isolation for your transactions, or row versioning for transactions, or storing temporary objects. That TempDB database is maintaining all that for every database on your instance. Every database shares that common TempDB for those types of objects. Well, with ADR, because of the structure of ADR, one of our key components, which is known as the persistent version store or PVS, replaces that and is going to be stored at the database level, which also is going to reduce the contention of accessing the TempDB. So additional performance improvements. So not only is it helping our recovery process, it's helping us with managing our transaction logs, rolling back and development, rolling back for error handling, reducing contention on the TempDB. And one item that's not on here that I keep forgetting to put on here is because we have a smaller transaction log, that's also going to speed up high availability and disaster recovery when I'm going from moving the transaction log from the primary replica to the secondary replica. It's amazing. So there is two downsides. I've been meaning to make a slide, but it's not really worth a slide. There's two downsides to ADR. Everybody says there has to be a downside. One, yes, your database is going to, you're going to use more space for your database, specifically for the persistent version store. That's going to take more space, but you're also saving space by you're saving space in the TempDB. You're also saving space in your transaction log, so that kind of offsets. Plus, with the persistent version store, there's a cleaner operation that goes through and cleans up your persistent version store. So that one downside is not really, it's a little downside because you're going to use more space, drive space for your actual database, but that offloads based off where you're saving space and improving performance in all these other areas. The second downside to ADR is that your updates, any update statements take 13% longer to run. Technically 13.8%. Where did I get that number? I'll show you later on in a later slide. But again, offloading, having a little bit slower update statements versus saving hours on rolling back, recovering, saving transaction log space, far outweighs any slower update statements. We're talking about it takes a minute to update. Now it takes a minute and 10 seconds. So the benefits far outweigh those two. Those are the only two downsides I've seen. If you do see another downside, let me know as we go through. Then again, I've been playing with ADR since, well, before 2019 came out. The pre-release version or the whatever, the public preview, private preview for a while. So those are the main ones I've seen with customers. So that is what ADR is. Didn't mean to talk that long, but I got excited. So how to enable it? Azure SQL, it's on. That's easy. That was easy. 2019 and later, I just type in alter database, name of the database, set accelerated database recovery equals on. That's it. That's all I need to do. And it's on. No other configuration needed. That's amazing. It's built in. Now you optionally, or if you don't specify, when you create the accelerated database recovery, turn it on, it will store that persistent version store. That's basically my row versioning storage. That's where I normally would store row versions of rows if I have that snapshot isolation on that's normally stored in the TempDB. When I enable ADR, I get that one of the components is the persistent version store, or PVS, that I will call it from now on. By default, if I don't specify, that PVS is stored with your database, or more specifically with your primary file group, wherever your primary data file is located, which is fine. But you can also possibly increase performance by moving PVS to its own drive. If you have another SSD drive where you can move your PVS, and to do that, that optional component there, persistent version store file group equals, and just create a file group to store the PVS. And surprisingly, I'll show you that in the demonstration. So that's how you enable it. Okay. So let's look at our current database recovery process. And I updated the slide just today. So if you've seen this presentation previously, I added one thing because I couldn't remember what area stood for. I put it in the title bar down there at the bottom. Our current data recovery process is technically called ARIES. I have to look at it. Algorithms for recovery and isolation exploiting semantics. I have no idea what that means. I know what each individual word means. I don't know what it means together. But that's the technical definition of our current database recovery process, what we've been using since 1998 or before, but I just know 1998 since then. It's a three-phase process that we've been using to recover a database, not just restore, but recover maybe a transaction failed and I need to roll back a transaction, or the server reboots, or Bob trips over a power cable. That darn Bob. So phase one is the analysis phase. The analysis phase, this will still be true in our new and ADR, Accelerated Database Recovery. It goes through and analyzes everything from our checkpoint. If you would like to get into checkpoints and transaction logs, that's a whole nother session. I might have a blog post on that, or it might be on my list of blog posts I mean to do. But a checkpoint is how often are your data pages written, your dirty data pages are written from the buffer pool into your physical data file, your MDF and or NDF files. So that's a normal part of writing data to your data files. Well, if during the recovery process, if there was a failure at the point of failure, the analysis phase is going to look from the checkpoint to the end of your transaction log. That's the whole purpose of the transaction log for recovery. If you are in full recovery model or even simple recovery model, you still do the analysis phase. So you're going to check what transactions need to roll forward or roll back. Specifically, what transactions have finished, have committed, and which transactions have not finished or have not been committed. So the analysis phase normally takes pretty quick, milliseconds, couple milliseconds. Then after I have that phase, then I have my next two phases, redo and undo. Redo redoes all those statements from the oldest active transaction. So if you look in your transaction log, you can look for your minimal logical sequence number. I always have a hard time saying that. Minimal logical sequence number, or minimum LSN. It will look within your transaction log for the minimal logical sequence number, and from there replay all the transactions that have been committed, basically to make sure that they've been written into the data file. So it rolls forward. The undo phase rolls back. Anything that did not commit or was not finished, I will roll back to the oldest uncommitted transaction. How far back is that oldest uncommitted transaction? This is our major pain point. The whole reason we have ADR. We have some of those other side benefits, but the main reason we have ADR is that undo phase could take hours. That undo phase goes back to the oldest uncommitted transaction. That means the active portion of your transaction log, or the active VLS, virtual log files, I have to go all the way back to the transaction that's been running the longest, because the oldest uncommitted transaction, or the oldest, let me rephrase that, the minimal logical sequence number, the min LSN, is the beginning of that oldest active transaction. And I have to keep my transaction log open currently, again, current process. I have to leave that transaction log, that transaction, I have to leave it available and leave the active portions of the transaction log open or active while that transaction is still running, just in case I need to recover and roll it back, which means my transaction log just grows and grows and grows depending on that transaction. So if that transaction takes 10 hours, they're saying, John, a transaction that takes 10 hours, it's possible. If I'm doing bulk imports and I'm importing millions of records, if I have one of those transactions, I have a customer that imports, well, I have a lot of customers that imports a lot of data, where that import process that takes hours and hours and hours. If something happens, so someone trips over the power cable, that has to roll back. How long is it going to take to roll back? All the way having to roll back from the end of the transaction log to the beginning of that oldest active transaction, which was 5 hours ago, which means my recovery time is directly proportional, or almost, to the amount of time the transaction was running in the first place. This is our huge pain point that we have, because If that transaction has been running for 5 hours, it might take 5 hours to roll back that transaction or to perform that recovery process. So we want to take that from hours down to milliseconds, as we will see coming up, actually very, very shortly in the next 5 minutes. One other item here that I kind of skipped over a little bit. I always do this, I skip over it. And we're going to put the pieces together here. But during that redo process, another factor that I've been meaning to add on that first slide is that after the redo phase, my database is only partially available, which means it's possible for some people to access a table as long as it's not part of that oldest active transaction or any of the transactions that need to be rolled back. 90% of the time, my database is still going to be locked out for most people. So they can't access that database until it's fully available or after the undo process. So we still have those locks in place. So there's a sixth benefit that we'll see, because with ADR, after I do the redo, all my locks are released. Release the locks. So that's immediately available even when the undo phase hasn't happened yet, as we will see. So this is our current database recovery process, what we've been dealing with for a very, very, very long time. As I mentioned, some of our common implications of our current process, our recovery time, not just recovering a database, but also rolling back transactions. Recovery time is roughly proportional to that longest running transaction. Rolling back operations also takes a long time, as we just kind of mentioned. If I have to cancel a query or there was an error that had to roll back, that's going to go back I have to do all the undos all the way back to the beginning of that transaction, which could take a minute, could take hours. And because I have to keep every part of that transaction active, or the active portion of the transaction log active while that transaction is still running, means my transaction log is going to keep growing and growing and growing and growing, which if I don't manage my transaction log, if I don't initially give it enough space to allow for that growth of that long running transaction, it could run out of space, or I might need to enable auto grow, which might lead into some other issues of maintaining that log. Unruly logs, that I have to maintain those logs, which also is going to slow down log shipping or high availability features. All these kind of tie in together, all these big pieces together. So common implications that we're running into that's going to be solved. So let's look at our 4 core components. Then we'll look how they work into our recovery process to improve our recovery time and all those other items we mentioned. So the big one, the big item, is the persistent version store. This is a persistent row version in the database itself rather than the TempDB. So if you're currently using like snapshot isolation or row versioning, that is now going to be offloaded to the TempDB, which reduces concurrency on the TempDB from all your other databases on your instance. So it's going to improve your other databases as well on your instance, because they're not fighting for contention, or at least with me or with my database. But those row versions, it's going to have a different version of each row. So as I'm working with data, I can just read the data I'm looking at, and then if I'm modifying data, I'm modifying that row. So I'm working with 2 different rows. I'm using more optimistic isolation as opposed to pessimistic that we use with locking. But each version of the row will have the previous state of the data and a transaction ID of that version. So the benefit of this is having that persistent version store where I'm storing those row versions, that if there is a failure to communicate, if there's a problem, instead of having to roll back a transaction, what were all the steps I was doing to update those records, all I say is just go back to the previous version, which takes, boop. That's how fast it goes, boop. If you listen closely to your server, you'll hear it, it'll go boop, milliseconds, because it'll mark the row that is no longer active and say, well, we had an error, so this is no longer the active row, mark it as aborted or terminated, and roll back to the previous one. So that's how I can immediately recover, because I'm just going back to the previous version of that row, as opposed to having to undo all those, undo all the parts of the transaction to the oldest active transaction. I don't have to do that now. I just go to the previous version. That's where the magic happens, which also means my transaction log is smaller because I don't have to keep track of everything that was happening since the oldest active transaction. I don't care anymore because that information is in the persistent version store. So that's why my transaction log is smaller. And I did mention one of the two downsides of accelerated database recovery is now I have a persistent version store, which is going to take up disk space. Yes, but remember, I'm saving space now in the temp DB, but also saving space for my transaction log because I don't have to keep track of every single part of a transaction in the transaction log. So I'm saving space there. But also the cleaner, as we'll come up back to, the fourth component there, does go through about every minute and cleans up the persistent version store. And in SQL Server 2022, I just read this yesterday, the cleaner actually operates more faster, more efficient. I haven't dug deep into it yet, but in 2022 actually improves the performance of the cleaning process, which, as we'll see in the demonstration, happens pretty quickly anyway. So as I mentioned, that persistent version store, yes, I'm using more space. I'm using for those row versionings. I'm offloading that from the temp DB, and it's going to keep my transaction log smaller. And ADR has its own self cleaner, which we'll walk through. Now there's the other parts here, the logical revert. This is the asynchronous process that goes through and performs row level versioning based undos. So it basically keeps track of all those aborted transactions. So if I had those row versions, I probably should make a slide instead of using my hands. Those row versions, then I basically say as I go through, well, this transaction is no longer there. So undo and mark these a roll back to the previous version. So the PVS is basically just storing the row versions. It's a logical revert that goes through basically during that, well, an asynchronous process in the background. I almost said the wrong thing. It goes through and performs rollbacks using the recent committed transactions. And as it does that, it immediately releases any locks. So immediately allows people access back to those rows, the current version of that row. So it's a logical revert that's logically reverting my transactions to the committed row. So if there was a rollback. Excuse me. Now, all these operations we've been doing, or everything we've done up to this point, is for versioned activities. Anything that's version, like any insert, update, delete, create, alter, drop, the different things that you would typically see in a versioned, or where you have different versions of a record. Now, there are some operations that's stored in the transaction log that are not versioned, that we're just performing different activities, like bulk operations, where transaction log it just says, hey, we're doing a bulk import. Great, what are you importing? We're just updating these extents. These are the extents we're updating. I may not have individual version rows there, or I'm placing locks on a row or page or a heap or wherever I'm placing a lock. Those are not really versioned operations because I'm not modifying individual records. Either with the insert or update or delete or create, alter, drop if I'm modifying objects. There's not versions. So I also need to keep track of this information. So my S log, my secondary log or special log, I call it special log, but it's technically secondary log. It's in memory. So it's not physically on the disk, it's in memory. Where I'm storing any of those non-version operations, it's going to be stored in the S log. So if I need to undo any of those, or any of those operations, non-versioned operations, non-row version based operations, I can undo those, just clear them out of the S log. Or I look at the S log, what's currently in memory, not actually on disk, so I don't have to read the disk like I would if I was looking at for these items in the log previously. I can just look at the S log and say, okay, any of these locks or bulk operations that need to recover, we're not using those anymore. They do get persistent on disk or during checkpoint. So in case I do need to roll back and just look at the previous version of the S-log, and periodically truncated. So it'll try to kind of clean itself up as well. But it's used to accelerate the redo and undo process by for those non-versioned operations. And then bring in the cleaner. The cleaner is my favorite. All it does is go through and clean. It's just sweeping up. You got time to lean, you got time to clean. And that's what the cleaner does. It goes through and cleans up your persistent version store. Any of those rows that were marked as terminated or aborted by the logical revert, there's no reason to have that anymore, because that row that was being updated, or it was in the process of, here's our current row, here's a row that was being updated, and the logical revert says, oh, we recovered, we're rolled back, we don't need this row anymore, so we're going to mark it as aborted. The cleaner goes through and just looks at all those and said, oh, we don't need that. There's no reason to keep track of this information. So it goes through and cleans those and gets rid of it to, again, reduce space on my persistent version store. Awesome. So make sure my persistent version store does not start growing unruly like our transaction log does. Our transaction log currently gets unruly if we have that just one long running transaction. Here, the cleaner is going through with our persistent version store and saying, we don't need that row anymore. Row by agonizing row. We don't need those anymore. If you listen closely, you'll hear say row, 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 no. So those are the four components. Where do they work in? Going through one at a time. Maybe our demo ability, I geeked out a little bit there. Where do these components go in? And then we'll get into our demonstration. Actually, 2 more slides and we'll get into the demonstration. The analysis phase is still the same, but it'll reconstruct the S-log, what's in memory and what's the last S-log that was persisted to disk. So look at what are our non-version operations. So the analysis is what needs to roll forward, what needs to roll back. That's still the same, but it's also going to look at the S-log or reconstruct that secondary log to look at what are our non-version operations. The second phase is actually split up into 2 parts, 2A and 2B. 2B or not 2B. Our not 2B or 2A actually does the redo phase, all the non-version operations. We'll roll those forward because I don't care about rows that happen before the checkpoint, because anything happened before the checkpoint is in that row version store. That anything that rolled forward, I have that current version in the version. I don't have to recommit those because they're in the version store. All I need to redo at this point is since the last checkpoint. So 2B is going to, after that logical revert went through, it said, okay, these have been committed. All I need to do is look into the transaction log since the last checkpoint and redo those, which is what, last 5 minutes, last 30 minutes of data, depending on what you set your checkpoint options are. I think the default's 5. I could be wrong on that. And at this phase, all my locks are released because I don't have to lock out anything on the database because everything's versioned in that row version store. So previously, I still held locks on anything that needed to be undone. Here, release the locks. And then my undo phase, which previously I had to go back and undo everything all the way back to the oldest uncommitted transaction. Since I'm using row versioning in that persistent version store, I don't have to keep track of that information. That information is going to be aggressively truncated, as we'll see in the demo. All I need to go back for is go back everything since the oldest checkpoint, which again, depending on your settings on your server, could be just look at the last 5 minutes, which is going to be, boop goes the dynamite. We're going to see this in the demonstration. All right, now, sorry, I can take a drink. I've been talking for 40 minutes straight. That's amazing. How does he do it? All right, where did I get all this information other than my friends at Microsoft? ADR in its infancy, I think I said that right, was originally called constant time recovery. I'm going to put this link in the chat box. I always do that. If you actually want to see a white paper, we'll try that again. There you go. If you want to get into the white paper and the nitty gritty of everything ADR, you can read this white paper on constant time recovery. And it goes through and they analyzed and went through all the different upsides, downsides, the architecture, everything on CTR, what accelerated database recovery was originally called. On the, as I mentioned, that there are two downsides to ADR. One was the persistent version store is going to take more space, but remember that cleaner goes through and makes sure it cleans up. So it's not really that big of an issue. I know some people, oh, I don't want to use that much more space, but you're saving space from the transaction logs and tempDB, what would be in the tempDB, and you know the fast recovery time more than covers that, and the cleaner keeps that small. I said the second part or the second downside to ADR is your updates are going to be slower. According to this white paper, 13.8% slower. You won't see much different with inserts and deletes. I think it's like 2% impact on maintaining inserts and deletes. You can actually get this in for this chart here from that white paper. Now, I do want to point out, though, this picture is also an example of bad visualization. For anyone's doing visualization on PowerPoint slides, because on the left-hand side, this is the y-axis is measuring in thousands or 500s of seconds. This one's a measuring of in periods of 5 seconds. So this is not an apple and oranges comparison. Bad person who ever built that. I actually copied the picture from that white paper. So you can immediately see, though, the recovery times without accelerated database recovery or constant time recovery was being measured with your inserts, update, deletes, and the different phases. Analysis where you do an undo was being measured in the 500s, thousands, 15,000s, where your update of 200 million records took 3,000 seconds. 3,000 seconds. Where, if I look on the right, we're measuring in 5 seconds, 5-second intervals. So the picture on the right doesn't even fit. It's like in this little itty bitty part there on the picture on the left. But if you do look and see, okay, these are two separate, they're not apples and oranges, you can immediately see that recovery times with ADR, even the worst thing with deleting 10 million records, which I'm not, that seems weird that deleting 10 million records would be slower than deleting 200 million, but that's all right. You can immediately see the slowest thing is 15 seconds. That's faster than pretty much anything on the left-hand side. Okay. Now, I'm surprised I haven't had any questions yet, but just in case, I do have an FAQ from the questions I normally get in this presentation. Will my database be larger? Yes, I think I've kind of talked about that. You'd want to monitor to determine the difference. As I mentioned, a lot of the database being larger with that persistent version store, a lot of that is offset by the extra benefits. According to the CTR, thank you. According to the CTR white paper, every 50 million modifications add a gig to your database. But again, remember the cleaner is going through and cleaning it up. Will it affect performance? I just talked about that. To get the actual values in that white paper I just gave you in the link, 13.8% utilization for update workloads, 2.4% for, sorry, my nose is itchy. I gotta itch my nose. 2.4 for inserts and all your other. How is PBS different than, will I need more memory? No. There you go. A meg. Just enough for the S log, which is in memory. So no. Whatever memory you have right now easily supports it. Very similar to the tempDB, I mentioned that. And you can kind of see the availability groups if you'd like to go more about availability groups. Okay, demonstration time. It's demo time. It's demo time. And this is my demo song. Okay. So I just made that up. Hopefully you enjoyed it. It'll be on the top 40. Is it simple to disable ADR? Yes. And I'll show you how. You just turn it off. Okay, so here's my demo. As previously mentioned, this demonstration code is on my GitHub. Look in the chat box. It's there. github.com/SQL MCT, SQL MCT. So here I'm going to build a database called ADR demo. Just going to create a simple database ADR demo with a data file and a log file. Has no impact on indexes whatsoever. Indexes are a completely separate thing. All right. So ADR, it might, I don't want to say whatsoever, but will add more time to complete. Shouldn't have any effect on what you do with indexes. I've actually not tested that, but off the top of my head, I can't think of anything as far as indexing. Okay. So I'm not really doing, let me think on that one. That's a new question, but I can't think of anything as far as indexing that would be different. Okay. So I created the database. Now I'm going to create, sorry. I'll come back to that question later. We'll come back to that at 4 o'clock because got to get through the demo before 4, but I'll still be around for those questions, those additional questions. Okay. So I'm going to create a file group just to show how to store your persistent version store in a different file group. I could have done that when I created the database, but I just wanted to highlight that I was creating a file group. Now you may notice that I am putting my file group on the same drive as my data file. That's not good practice. If you're building a file group, put it on a different drive, but I've only got the one extra SSD drive. If I had a different computer. Okay. So here I'm going to use that ADR demo. It is a 2019 server database, so should be 2019. I am going to change the compatibility level to 140. So that SQL Server 2017, just to show that I'm on a 2019 server, but I'm enabling this database is going to be a 2017 version. So it's a 2019 feature, but it's a 2017 database now because I just changed compatibility level. And I can verify that by looking at sys databases and ADR demo. Compatibility level is, I believe it's SQL Server 2017. Accelerated database recovery is currently off because it says 0. So I'm going to demonstrate what happens without ADR. Then I'll show you with ADR. All right. Next thing, I'm going to insert 750,000 records into that database I just built into a table called ADR test. Why? Because I need data to work with to delete and update and stuff like that. So I just created a database. So up to this point, I'm just creating a database, create a file group, change my compatibility level, and I create a new table in that database and added 750,000 records. Now I'm going to add a brand new non-clustered index. We're talking about indexing. I will play around with that, but I don't think it has any effect. I'm actually adding an index here to speed up my search results because otherwise this select statement says there's 750,000 records. If it was in a heap with no indexing, then this would take 30 seconds to run this query to retrieve 750,000 records. Even now it's taking 10 seconds, 11, 12. And this, I'm just reading the records here, just to show that the records do exist. Again, nothing with ADR at this point. I'm just building the demo so we actually have records there. And that they still took 17 seconds with the non-clustered index. Again, nothing new at this point. Okay, take a drink. All right. Now we're getting into the demo. First thing, hey, John, that's me. Let's delete records. And I'm going to manage how long does it take. Again, this is without accelerated database recovery right now. So I'm going to begin transaction to delete all those records I inserted. That's silly. Why would you ever do that? For a demonstration. So it should take about, the delete process, I think it takes about 20 seconds to delete all 750,000 rows. Notice I say there's no commit yet because I want to check that they did get deleted, and then we'll do a checkpoint. Okay. So CPU time was about 8.2 seconds. Elapsed time was 26 seconds. I'm going to copy that, and I'm going to paste it, come back. I'm currently on line 55. I'm scrolling down to line 102, and my demo code 102 to put the time there, what we just did. Okay, scroll back up. Was it line 55? Yeah, line 55 is where I was at. right, so now I'm going to check, are those records still there? Nope, they're gone. So they're gone. Oh no, I just inserted them. So again, up here, I inserted 750,000 records just so I could delete them. Created an index, I selected, and then I began a transaction and deleted them. I did not commit. I did not commit. And when I selected, I did see that they were deleted. So those data pages are still in the buffer pool. They've not been committed. All right. So now I'm going to, let's look at, I'm going to check the size of my transaction log. Again, without ADR, without accelerated database recovery before and after my checkpoint. I execute, and the size of my transaction log before the checkpoint was 741 meg. I'm using 95.5%. After the checkpoint, still 741 meg, but I'm using a little bit more because I have an entry now for the checkpoint. Again, this is our current process before ADR. I know Tom's looking at, we got 10 minutes, we got 9 minutes. We got about 9 minutes left to demo. We're going to be right on time. Okay. So I did the checkpoint just to see what is our transaction log. It has to maintain all those 750,000 delete statements because I deleted, I didn't commit, so I have to keep that in the transaction log. That's why my transaction log is so big. But now I'm going to roll back. I'm going to roll back that transaction. I didn't commit, I'm going to roll back. So it's basically going to undo the delete. I just deleted those 750,000 records. I'm rolling that back so that, one, we can see how fast a rollback happens. That's how fast a rollback happens without ADR. That was actually not too bad that time. How fast it rolls back without ADR, without accelerated database recovery. Again, I'm undeleting those 750 rows. Where do I want to paste that at? I should have read my note. Here we go. So how long did that rollback take? About 5 seconds. The elapsed time was 12.3 seconds. Okay, let me go back up. So we delete? We did that checkpoint. I want to make sure. Let's check to see if it did roll back. So if I select, it takes about, it's going to be 10 seconds again. But we can see that the records did come back. We have all 750,000 records. So we inserted the records. We deleted the records with the begin transaction. We deleted them. We did not commit. We checked our transaction log, and we saw that it didn't matter about the checkpoint. I had to keep track of all those 750,000 deletes just so I could perform that rollback to roll back the delete statements. So our records are back. Okay. All right. Now the magic hands. I'm going to turn on accelerated database recovery, and I'm going to turn it on. We had a question. How do I disable? Now it's off. Now it's on. That's how I enable and disable. Oh man, it's so difficult. So I'll execute. Now my ADR is on. Can we verify? Yes. Yes, we can. It is now on. All right. We do have a new dynamic management view called Transaction Persistent Version Store. This allows me to check the size on my persistent version store. I'm going to keep track of how many aborted transactions do I have. Currently, it's 0 size because I haven't rolled back. I haven't done anything with ADR. I just turned it on, and we do not have any transactions that have been rolled back or been marked as terminated. Now I'm going to delete those records again. I still left at the same compatibility level. Again, I changed the compatibility level. I left it at 140. So that's a 2017 version of the database. I'm still on a SQL Server 2019. I just kept it the same. So it doesn't matter, but now we know. Did I do? Okay, persistent version store. Hopefully that answered your question. I know I have a few questions out there I need to answer. I get 2 questions I still have. So let me go ahead and I'm going to delete the records. Mo, the first one, as I was thinking about it, as I was doing the demo, I don't think there's any impact on indexing, creating indexes or rebuilding or reorganizing. It might actually improve the more I think about it. For AG, it doesn't matter. because the logging is still, whether it's sync or asynchronous, does not matter on your availability groups. As I was thinking in the back of my head, because the process is still going to be the same. Good questions. What are the best candidates to get started? Any database. Any database with a lot of transactional activity. You might want to test it out first if you have databases that do a lot of updates, but anything that's not doing a lot of updates. Okay. So before and after. So when I did the update previous or did the delete previously without ADR, it took 8 seconds CPU time, but the elapsed time was 26 seconds. CPU time took a little bit longer with ADR, but the elapsed time was a little bit smaller because there's less activity having to go to the transaction log, less those log writes. I don't want to say log writes, but going to the transaction log. So you can just the delete statement. Okay. Let's check the transaction log size. One of the benefits of ADR, remember previously without ADR, the size of that delete statement filled up the ADR 741 megabytes when I did the checkpoint. Now, since I don't have to keep track of all those 750,000 deletes, now the size, I only have to keep track of what happened since the last checkpoint. We'll come back to that. No to that. But you can see it's much smaller. And then when I did the checkpoints, even smaller still, because I don't have to keep track of all those individual transactional activities for that delete. Let's look at our PBS execute. It is bigger because now I'm keeping track of those row versioning since I turn on ADR. Currently, I've not rolled back any transactions. So all my data, so my PBS is larger. But how much space was I saving with my transaction log? I looked at my transaction log. Let's look at that again. It went from 741 meg to 201 meg. I'm using 83 meg for the PBS, so still saving, if I do the math, like 400 meg. I was doing the math in my head. Okay. This is where the magic happens. Everything we did, hands, magic. Remember when we rolled back last time, it took 12 seconds to roll back. And that was 750,000 records to roll back, deleting those records. We've already seen that our transaction log is much smaller. Rolling back, I have to wait for it. How long does it take to roll back? 1, done. What? Done. It didn't even register, 0 milliseconds. Are my records back? All 750,000 records are back. So the rollback process, the big benefit of ADR, my transaction log is going to be smaller. We saw if I had to maintain all those deletes, filled up my transaction log up to 741 meg. Since I'm using ADR, yes, my persistent version store was using 83 meg of space, but when I rolled back, kept my transaction log smaller. When I rolled back, all those row versions said just go back to the previous version of the row, and it just immediately marked it as this is the active row. So that took 20 seconds to come back, or 20 seconds. We actually saw those, but the elapsed time less than a second as compared to 12 seconds. That was 750,000 rows. Let's look at the records are available. Let's look at our persistent version store. I don't know if I stalled long enough. Yeah. So I do have one rollback, one aborted transaction, saying we rolled back those 750,000 deletes. So my PBS is still 82 meg. The cleaner has yet to come through. The cleaner is going to come through here in about, I think I installed, I need about 30 more seconds. But if I highlight the checkpoint, now I've rolled back everything, what's the size of my transaction log? I'm now down to 17 meg. Well, before the checkpoint, 346. After the check, because I don't have to keep track of all those transactional stuff. All I have to do is keep track of everything that happened since the last checkpoint, which is basically running the statement at this point. Okay, let's look at our version store again. Now that the cleaners come through, the cleaner went through, rolled back, or removed all those stale row versions, and I went from 80 meg down to 0.07 meg on the persistent version store. So that's the cleaner in action. I just had to wait a full minute. for it to go through and clean up. Okay. Now there is another section here on looking at updates. Like I said, updates take longer to run. So if you want to test that out, I do have the code. Again, there's another example of turning ADR off. Then you can test it doing updates, going through the entire process again, turning it back on, and then comparing and contrasting. Again, if you want this code, it is on my github.com/SQLMCT. But I know I still have questions out there that I will be happy to answer, but I promised Taub 4 o'clock for the official video and for the people on the West Coast. So I'll come back to those questions. Taub, I'm turning it back over to you for a moment. But yeah, 4 o'clock exactly.
John, thank you so much. And like you said, I would just want to respect people's time because we officially declared it's our meeting. But if you have time, I will be hanging around just to listen to some of the answer of the questions.
Yep.
So, folks, if you have questions, comments, please stay back. We'll leave the meeting open as long as John answered the questions. But if you cannot, you can leave. I'm not going to stop the recording till John has the questions answered. So you can come back to our YouTube channel and listen to the answered question and answers. John, go
I
ahead.
know I would. Oh, sorry. I know I went through that demo pretty quick, but I was trying to fit everything into an hour exactly. All right, so let me walk through the questions to make sure I hit all of them. You are doing great. Thank you, Kachan. Tammy, will I need more memory? I think I answered that one in line, but not anything significant. Whatever memory you have right now, you're not going to see a huge impact, especially if you have 64-bit servers that you have now. You're not going to see that you would need to add. And is it simple to disable ADR? We showed that, Stephen, we turned it off. What are the best candidates to get started? That's another question from Tammy. Any databases, if you want to, well, you practice my code, but a production environment, or sorry, development testing environment, start off with those with less update statements, where you might be doing insert or deleting transactions. Try to work with those because, like I said, the biggest impact will be with the updates that you might see. Or you might want to reverse that. Start with the databases you see a lot more updates and see what the impact is there. I think I answered Mo's question on how is the impact of index rebuild on a large table? Will add more time for it to complete? And I was trying to think of that and talk at the same time. That's an interesting question I've not had. The index process shouldn't affect here as far as building the index because it'd be the same as if you're building an index on any table that you're currently using read committed snapshot isolation, if you're using that or not. Because you're just indexing on that, creating a non-clustered index on that table. So there shouldn't be any impact. If it is, it's minimal. For the availability groups, as far as the transaction logs, does it have to be synchronous or asynchronous? Off the top of my head, I don't think it matters because for availability groups, it's just going to grab your logs and then move it over to the other location, or move it to your replica, I should say other look, but where your replica is. I don't think it affects there with availability groups, which I think I had let me go back. I have a thing on availability groups here. As far as loggers communicates oldest versions needed to primary, can actually speed up failover because the undo is very fast going through the undo process. Secondary must be restarted. Without ADR, the temp DB is lost, so versions are lost. So there are a few things there with ADR, but I don't think anything specifically with synchronous or asynchronous. Setting that up with availability groups, I don't think there's anything that would touch on it. As far as that, I could be wrong, just off the top of my head. Change compatibility level, that was, it should be at least 2019, but you saw I did change my compatibility level back to 140. I just didn't do it again the second time, but I could have. That was just demo. Ruben asked, I'm slowly catching up. Does a DB database have to be removed from an availability group to enable ADR, like to enable broker services? Oh, that just hurt my soul. Talk about broker services. I know that boils down to planning beforehand, but good to know. Good question. I don't think it does. That's something I would have to test. Off the top of my head, I don't, because broker services is basically handling communications between your availability groups, primary and secondary. ADR is, I don't think you'd have to remove the database. It might have to be offline. Depending. I don't think so. It's just changing a property on the database. So I don't believe so. Is there advantage for backup and restore for house? When you first typed that in, I wasn't sure where you're going with it, but now I know where you're at. That's a yes and no. Is it how? Sao Chen? Is it 8? I think H might be silent. I don't want to mispronounce it there, but is there an advantage with ADR turned on for backup and restore? Yes and no. It does not have an effect on backing up and restoring. It does on the recovery. What I mean by that, when you're restoring a database, there's 2 phases of restoring. There's a restore phase and the recovery phase. The restore phase just copies the data from your backup back to disk. And then after you restore, then you have the recovery phase. So this recovery phase, yes, that's where this would come in, but it would not have effect on your backup, the actual backup phase of the restore phase. It's just once you restored, and then after the restore, you would then need to recover. That's where this jumps in, and your recovery would be milliseconds, as opposed to having to wait, play forward and play back the entire log. So you do. That was a yes and no. Hopefully I answered that one. I got a thumbs up. Oh, wow, there's a lot of them. Okay. Kanchan? Kachow. Is it for cars? Kachow. Can we safely say that this feature is for very large databases to accelerate their recovery time after server reboot or sudden crash only? Yeah. On an OLTP system where I have more insert, update, delete, I should avoid it, or is it not as beneficial for those? That's one of those our SQL Server questions that you always get in the SQL community. It depends. Definitely very large databases, you're going to get benefits. For smaller databases, and by smaller, I'm not sure the technical definition, 100 gigs or less. If it's you're still going to get benefits. Again, it's going to slow down your insert, update, deletes, but the recovery process and you're managing your transaction logs, even for smaller databases, you could get some benefits. So it might be something to test. But to answer your question, yes, you're going to benefit more from larger databases to accelerate that recovery time. But you also benefit from offloading from the TempDB, the concurrency issues with TempDB database. You're moving your row version stores closer, your temp object closer to your database. So it's going to affect performance there. It's going to improve the performance of your transaction logs. You're going to have smaller transaction logs, so it's going to save space. So that's something to test out, but I believe that is a good, we can safely say, but it's more of a depends. So test it out in your environment. Tammy says, that was an excellent presentation, well explained and demonstrated. Well, thank you. I'll give you a little heart sign. Great presentation. I enjoyed the jokes. Did I tell any jokes? I might have. It was Bob, wasn't it? Bob in the server room. Thank you. There's a note. Thank you. Excellent presentation. Another excellent job. I guess I can thumb up all these. Well done. Thank you. Oh, there's a question. Breck, with CRM Microsoft Dynamics 365 MaxTop equals 1, the impact. I only understood one of those words, and it was 365. I'll be honest. MaxTop equals 1. Well, actually, none of this will have an effect. With CRM Microsoft Dynamics, I've not worked with CRM Microsoft Dynamics. I don't know how it works. I'll be honest with you, I'm a SQL Server guy. I do know that MaxTop equals 1 is always going to negatively impact your server because you're turning off parallelism if you have MaxTop equals 1. I could talk for another hour on max stop equals 1. And max degree of parallelism and cost threshold parallelism, but only from a SQL Server side. Like I said, I cannot speak about dynamics. I guess I could. I just did for 2 minutes. I know nothing about dynamics. Or don't ask me SharePoint questions either. With commission, or we had another great thing. Thanks a lot for answers. Thank you. Well, compression process is impacting if the table compression is enabled page or row. Another great question. It does not affect your data pages. So this is only the only pages it would really affect is it's not affecting any of your pages. I was trying to think of it even affect the dirty data pages in the buffer pool. But it's not even affecting those because your row versioning, your data is still going to be on your data pages, whether it's page or row, whether it's compressed. So there's not going to be any effect on paging, any of your data pages or anything you do with the data pages, because this is happening at a higher level, I guess you would say. Hopefully that answered your question there, Mo. Thanks, Stephen. Single-threaded transactions. A lot of food for thought. Cheers. Yeah, the bank's opening up. A lot of food for thought. Single-threaded transactions. Threading would not have any effect whether your transactions were single, because this affects whether it's single or multi-threaded transactions. And at this point, if you're on 64-bit processors, almost all your transactions. It is recorded, Julie. So, okay. I think I answered single-threaded transactions. Threading at your processor unit level has no effect here as that either. I was getting ready to get into weight types and threading and log weights. It could actually improve. It actually improves weighting with your, is it log rates when you're flushing the buffer or the log cache into a log. So it can actually improve performance of some of your transactions, but no single-threaded versus multi-threaded really has no impact here. Food for thought. Yes, Julie, it was recorded. And if you don't want to watch this recording, it is recorded. It's probably on YouTube already with less jokes or different jokes if you wanted the B-side version. All right. Mo asked, my last question, TDE impact if you test it. Thanks a lot for the presentation. I'm not tested the TDE, transparent data encryption. This would not have any impact on transparent data. Your TDE is where you would have any performance because you're encrypting. I will say that for Azure SQL databases, both ADR and TDE are on by default. So if you ever wanted to test this out, you can, again, use my code if you wanted to. But if you have an Azure SQL database, both those features are on by default. Transparent data encryption and accelerated database recovery. And Laura says, Bob, that darn Bob, he's always in my server room, tripping over cables. He's got big feet, trips over all those cables all the time. That darn Bob. All right, did I catch up with the questions? Am I recovered?
Yes, you did. Yes, you did. So,
oh no, I missed one for Julie. Oh, I went over, so I got interrupted. Am I able to recover to a point in time? I thought that was, can I recover to a point in time in the recording? Sorry, Julie. The answer is yes. It has no effect on restoring. So your restores would be normal. Your restores would just be normal. The recovery happens after your restore process. So sorry about that, Julie, if you missed that, but there's the answer. Now, Tao, this one's up to you because Lee has a question for you. And he just answered it. But I think I'm done, Tao. Unless there's other questions, I can keep going.
No. Thank you so much, John, again. And thanks everyone for joining. Keep an eye on the meetup. And I will have all the recordings up probably by end of this weekend. So, John, thanks again for your time. We do appreciate that. I know how busy you are, so.
Well, the bar's open now, so I'll just run down there.
Okay, we stop recording. I'm going to